Alright, in this tutorial, we're going to be looking at a particular exponential function. Um, and you might expect a lot of real-world applications that deal with exponential uh, functions to use the base something like 2 or 10. But actually what you find is most of our applications use the base e, which is, you may have learned about this before, but E is Euler's number, and the number is irrational, but we can kind of estimate it to be about 2.718. And where that actually comes from is E is the limit as x approaches 0 of the function, or I'm sorry, if x approaches infinity of the function 1 plus 1 over x to the x power. And using calculus, you can actually figure out the exact number of e, which we sometimes refer to as the natural base. Now, when I graph the function f of x equals e to the x power, I'll use the second ln function down here and put e to the x. Let's go ahead and see how that looks. And just one of the unique features about the e to the x function is that it actually crosses the y-axis at a value of exactly 1. And that's another way to define e, is that its logarithm uh, is 1 at the value of 0. So the next thing we want to look at is how we would view transformations of the e to the x function, just like we did in the last video. Now, looking at this first one, we have f of x equals e to the x power, which we looked at the graph of that a minute ago. And we want to transform it so that g of x equals e to the 3x power. Now remember, since that's being applied to the exponent, that's really inside the function. And remember, things inside the function kind of do the opposite of what we would expect them to. A whole number like 3 outside the function would, expand the function. But what this 3 inside is going to do is it's going to contract it horizontally. So let's take a look at what that would look like. So I'll put another function in, e to the 3x. And when we graph it, as you can see, it compresses it quite a bit horizontally. You can kind of picture it being squeezed from the left and the right. Now looking at this next function, again, we have e to the x being transformed into h of x, which in this case is e to the negative x minus 1. And now notice we have two things going on here. We have the negative being added to the x, which is essentially inside the function. And then we also have this minus 1, which is being applied outside the function. So we want to take a look at what both of those are going to do to the function. And we know that the negative is always going to flip it. So since it's inside the function, that means it's flipped horizontally or across the y-axis. So if the normal function looks like this, then e to the negative x should look something like this, flip the other way. The other thing that's going to happen is it's going to be shifted by 1. And remember, since this is outside my original function, that means it's going to be shifted down 1. So we probably will see something like this when we graph it, and I'll show you a better approximation of that. So let's go ahead and get rid of this one. We'll put e to the x minus 1 and see if it turned out the way we expected. And yeah, it does look shifted down 1. And, well, I think I put e to the x. Let me put e to the negative x here. Sorry about that. So let's insert a negative there. Try that one more time. should be the other way. Yeah, shifted down 1 and reflected across the y-axis. Finally, again, this last function, j of x, is going to take 2 times e to the x. And notice it's affecting the base, so it's outside the function. And that means it's going to affect the graph vertically. So what that should do is stretch the graph vertically by a factor of 2. So let's bring up the calculator, get rid of this function, and we have 2 e to the x, and let's graph it. There's the first one, and second one does appear that it's being pulled, expanded from the top and the bottom. So let's see if you can recognize what would happen to a transformation on your own. All right, for this first example, you want to take a look at what p of x should equal if you have e to the x plus 2. And for this next one, I had to get rid of D because it was a copy of the correct answer. So you shouldn't be answering D for this, but then go ahead and sketch what the graph of e to the x plus 2 should look like.